You know, when you interact with an AI like ChatGPT, it really does feel like magic, doesn't it? I mean, it can write poetry, it can spit out code, it can even help you with your homework. But what's actually going on in there? Well, today, we're going to pull back the curtain and take a look at the engine that drives it all.
And just think about how far this has come. We're at a point where an AI is actually winning art competitions against humans. It's acing some of the most difficult professional exams on the planet. We're talking medical boards, the bar exam. This isn't science fiction anymore. This is happening right now.
And it's not just a novelty either. Look at this. Top universities are already putting this tech to work. At Columbia, it's condensing weeks of tedious research down to just a few seconds. Wharton students are using custom GPTs to get a deeper understanding of their classes. And over at Arizona State, it's even acting as a personal tutor for students learning German. This thing is already changing how we learn and how we discover new things. So that brings us to the big question, right? How is any of this even possible? It feels like we've leaped from a pocket calculator to a thinking machine practically overnight. Is it actual magic? Or is there something brilliant going on under the hood?
Well, that's exactly what we're going to break down. We're going to start with the so-called magic trick, then see how AI turns our words into numbers, explore this incredible universe of meaning it builds, and then get to the real game changer, the attention revolution. By the end, you'll see it's not magic, it's just math.
All right, first up, how do we get from words to numbers? We have to start here, because this is the biggest hurdle of all. The huge fundamental gap between how you and I talk and how a computer thinks.
Think about it like this. You could say to a friend, hey, what's 3 plus 2? Oh, wait, no, I meant 4. Your friend gets it instantly. They understand the context, the self-correction, but a computer, it needs super precise, literal instructions. Its whole world is built on logic and numbers, basically a whole lot of zeros and ones. Our messy, beautiful, flexible language is just complete noise to a machine. So the very first problem we have to solve is translation.
And that translation process starts with something called tokenization. This is step one. The idea is actually pretty simple. You take our language and you chop it up into smaller pieces that a computer can actually work with. And we call these little pieces tokens.
So, for example, the sentence, "the cat sat on the mat," gets broken down into individual word tokens. Then the AI looks up each token in its massive dictionary and assigns it a unique number. So the becomes 26, cat becomes 37, and so on. All of a sudden, our sentence isn't words anymore, it's a sequence of numbers. Now, finally, the computer has something it can actually process.
Okay, on to section 2, building a universe of meaning. Because, just turning words into a random list of numbers isn't enough, right? The number 37 doesn't mean cat. The AI has to understand the relationships and the context between all these numbers. It needs a map. And this is where the real magic starts to happen, with a concept called embeddings. Imagine taking every single token, every word, and giving it a specific address, like a set of coordinates, inside a gigantic multi-dimensional space. Now here's the key. Words that have similar meanings are placed close to each other on this map.
A great way to visualize this is as a giant cloud of ideas. So in one corner of this cloud, you'd find words like queen, princess, and woman all huddled together. Way over in another part, you'd find king, prince, and man. And in a completely different galaxy of this cloud, you'd find concepts like tractor or planet. The distance between these words literally represents how related they are in meaning.
What's so powerful about this map is that the relationships are actually mathematical. You can do a kind of conceptual algebra. Like the slide shows, if you take the coordinate for reina, which is Spanish for queen, and you subtract the coordinate for mujer, or woman, the answer lands you right next to the coordinate for rey, or king. This is how the AI starts to develop a kind of intuition. It's not just memorizing definitions, it's learning the very fabric of how our concepts relate to each other.
Now, section 3 brings us to the attention revolution. So the AI can understand individual words as points on a map. That's great. But language isn't just a list of words. It's about how they connect across long, complex sentences. And for a very long time, AI had a really bad memory problem.
If you look at the history, early models back in the 80s and 90s, things like Ngrams and LSTMs, they were amazing for their time, but they all shared a critical flaw. They processed information one word at a time, sequentially, and this created a massive memory bottleneck that basically put a hard cap on how smart they could get. They just kept hitting this memory wall because they were reading in a straight line. By the time they got to the end of a long paragraph,
that essentially forgotten what the first few words were even about. This meant they were terrible at understanding complex ideas or tracking relationships over long distances. It was a huge roadblock.
And then, in 2017, a research paper with a fantastic title, "Attention is All You Need," changed absolutely everything. It introduced what's called the transformer architecture, and its secret weapon, the attention mechanism. This was the breakthrough. Instead of reading word by word, attention lets the model look at the entire sentence, or even an entire book, all at once.
And here's why that's a game changer. Attention lets the model weigh the importance of every word in relation to every other word, simultaneously. So for any given word, it can calculate how relevant all the other words are to understanding its meaning. This is what lets it figure out that the pronoun it at the end of a paragraph is probably referring to the cat that was mentioned 50 words earlier. This ability to connect ideas across huge distances of text just shattered that old memory wall and unlocked a deep, true understanding of context. And that brings us to our final section. Not magic, just math. Okay, so we have tokens, we have embeddings to give those tokens meaning, and we have attention to understand the context. Now let's see how all this adds up to create the AI we use every day. When you get right down to it, what is a large language model really doing? Well, it's basically a superpowered autocomplete. Based on the trillions of words it's been trained on and the context of your prompt, it's just making an incredibly sophisticated statistical guess about which word is most likely to come next. And then after that, it isn't thinking. It's predicting patterns on a scale we've just never seen before.
And the key to that incredible scale is the transformer architecture itself. Because the attention mechanism can look at everything at once, it means the processing can be massively parallelized. Computers can chew through huge chunks of text all at the same time, instead of one word at a time. This is what let the models explode in size. GPT-3 had over 175 billion of these little adjustable knobs, or parameters, that it could tune to get better at predicting text. That kind of leap in scale was only possible because of transformers.
So, let's just recap that really quickly. First, the AI takes our language and chops it into numbers called tokens. Second, it maps those numbers into a rich universe of meaning using embeddings. And third, it uses the incredibly powerful attention mechanism to understand the full context of everything, no matter how long. You put all that together, and what you have is an unbelievably sophisticated pattern matcher, not a conscious mind.
So in the end, it really isn't a thinking machine. It's a reflection of us, a mathematical mirror of our own collective words, trained on a huge slice of the internet. It has learned the patterns, the relationships, and the very structure of human language. And this incredible combination of tokenization, embeddings, and the raw, scalable power of attention is really just the beginning. Which leaves us with one final thought to chew on. This isn't a mind, it's a mirror. What happens when it starts reflecting the parts of our world we'd rather forget